Hey guys, it's me again, Mr. V. I'm going to take you through this logarithms question that comes from the indices and logs topic. It is a non-calculator question, so it comes from paper 1. The skills we're going to be using here are simplifying, namely indices and power manipulation. So in other words, I'm referring to these formulas here, which are basically all the rules of all the powers that you've covered in previous years. You're also going to use a little bit of fraction skills here too. The main bread and butter of this question is logarithms, so we're going to be using the change of base formula here. We're going to evaluate some logarithms as part of the simplification, and we're also going to be doing some logarithm manipulation using these formulas here that are given in your formula sheet. And as well, of course, we're solving here, so we're going to be manipulating the equation and simplifying and just trying to make it as workable as possible until we narrow it down and get it down to isolate the unknown x. So there's a lot of things going on here. There's many skills happening, some skills which are new to you from the course, and some skills that you know from previous years or may have forgotten from previous years for that matter. And so it is no surprise that it is worth 7 marks. So it's a very juicy question, and hopefully if you are not quite up to this level of difficulty of doing questions like this, there's still lots of little bits and pieces here that hopefully you'll be able to learn from. So let's jump right in. When I first read that question, I actually wondered what the is that alphabet soup on the top line there. So if we try to decode what the question is actually asking, you could see that that top line there is actually just some kind of equation that appears to have a base of A, and the last term there has a base of B, so they've got different bases. So this is some kind of reference to an equation that has different bases. And so in situations where you're dealing with different bases, you would typically use the change of base formula, right? And so also you might be able to notice that if you rearrange that equation at the top there to make log base BC the subject, then you basically end up with the change of base formula, but with different letters. This is literally the change of base formula there, but it does on first sight appear to be quite confusing. Besides that, we could see that in the second line here, you could see that the logs have different bases, and so it is no surprise that we're going to have to change all of their bases to be the same base so that we can actually manage this equation a lot easier. And of course, the question itself tells us in the third line here that we need to change all of the bases here to a base of 2. So everything about this question is really telling us to use the change of base formula. And sure enough, that's what we're using in the first step, so that all of the logarithms that don't have a base of 2 now have a base of 2. So that's our first working step. And in the second working step, we're going to simplify these fractions that have resulted from using the change of base formula. So the denominator of the first fraction, I could actually evaluate that log because it is the log base 2 of 4. And I should be able to work that out without a calculator because it's essentially asking me 2 to the power of what gives me 4, and I know that 2 to the power of 2 will give me 4. So that bottom logarithm there, it works out to be exactly 2. The same thing is true for the logarithm on the denominator of that last fraction there. I can evaluate it by asking myself 2 to the power of what gives me 8. Well, that power would have to be 3. And so when I evaluate that logarithm, without needing a calculator, I can immediately write down 3. Also note that I used logarithm rule number 4 to make the power a coefficient for the fraction on the right hand side in this step. In just this particular working, I didn't use that rule for the first fraction, and I will be doing that in the next line of working. So that simplifies into our working step number 2. My next third working step is where I simplify these fractions. So the resulting fractions, if you simplify them, I could write them down as non-fractions. So the first fraction there simplifies to, instead of divided by 2, I can just write it down as a coefficient with a half. So halving something is the same as having 0.5 times that. And similarly, with that last fraction there, I see there's a 3 on the top and a 3 on the bottom. So using basic fraction cancellation, skills that I have from at least a few years ago, those 3's cancel out there as well. And so I land on working step 3, where I no longer have any fractions to worry about. So that's more or less the end of part A, and technically speaking, I could have left my answer as what you see here in working step 1, but it is kind of silly to leave it unsimplified, especially because we're going to need to do further work on that equation to solve it for part B. And so it is advisable that you simplify it whenever possible, even though the question itself doesn't ask us to simplify part A. Picking up my answer from part A, what I'm going to try and do now is to continue to simplify the equation as much as possible. So the first thing I could see there is that I've got these two terms containing log of x, right? And for the moment, I cannot group them because one of them has a power of 3 and the other one has a power of 2. So for the moment, these are not groupable terms. So what I'll do is I will use log rule number 4, and I will put those powers as coefficients for both of those log terms so that both of them become the log base 2 of x. And you could see in the working step number 1, for that first term there, the existing coefficient of a half is now joined by a coefficient of 3, so you just multiply them. And the same thing happens with the second term, where the power of 2 becomes the coefficient. And so now when I multiply those out and simplify them, we now go on to working step number 2, where both of these log terms are now groupable because they are both just the log base 2 of x. We got 1.5 of them here on the left, another 2 of them at the second term here. So finally we can group them together and we get 3.5 log base 2x's. So for the next part, now that I've simplified it to here in working step 3, because I'm trying to solve this equation at the end of the day, I'm looking to essentially isolate x and undo all the operations. So I'm somehow going to have to undo these logarithms and get rid of these logs. So the sneaky way that I'm going to do it in this particular case is I will basically try to make both sides of the equation to be simply log base 2 of something, right? So I'm going to use the logarithm rule number 4, but this time again in reverse, so that I make the coefficient into a power. So now that log base 2 becomes x to the power of 3.5. And now I've landed at a situation where I've got the log of base 2 of something equals the log base 2 of something else. And so therefore, logically speaking, I can now get rid of those logs because x to the power of 3.5 should be the same thing as 128. And another way of thinking about how we can get rid of the logarithms is we raise both sides of the equation to the power of 2. So what this means is that you've got 2 to the power of log base 2, which are opposite operations, and so they cancel each other out. So by this sneaky way, I got rid of those logarithms, and now I've ended up at a simple x to some kind of power equaling a number situation, where I'm going to have to just use my power tricks in order to solve the rest of it. So from working step 5 now, it's a little bit awkward because we got a power of 3.5. A lot of students struggle at this step because they're not really sure how to proceed to figure out what x is, especially without a calculator. When I first saw this situation here, the first thing that came to mind for me is there some way that I could break down any one of the sides of the equation here into some smaller factors? And so the first thing that I saw is that 128 there can be factorized into 2 to the power of 7. So I could write the 128 as 2 to the power of 7. So that's kind of like a smaller breakdown of that number. Once I broke down the right hand side, I tried to do the same thing with the left hand side by breaking it down or factorizing it somehow. And because I have a power of 3.5, I figured that if I take out a power of a half is quite useful because that's actually just a square root. And so I got quite lucky and I managed to factor it to the power of a half to the power of 7. And so I ended up in a very nice, tidy situation where both sides of the equation have a power of 7. So again, for the same reason that we managed to undo those logs because it was the log base 2 of both sides, we can undo these powers of 7 here because both of these bases have a power of 7, and so therefore we can undo that power, and we now land at x to the power of a half equals 2. So that x to the power of half there in the bracket, it must have equaled that 2 because they both have the same power. So whatever's in the bracket there with x to the power of half, it must have been equivalent to 2. So we have undone that power of 7 now, and now all we have to do is square both sides. Remember also that x to the power of a half is also a nice one to have, because the power of a half is simply a square root, and we're quite familiar with using square roots. So ultimately, we end up with the square root of x equals 2, and when we square both sides, we end up with x, and our answer therefore is 4.